Amos, and together with my groupmates, we're gonna show you how the dynamics works. And here are my groupmates.
Thousand years later.
What should be the angle of Jeff's arm when he released the ball in order to shoot it inside the cup, given that the distance of the cup from him is measured to be 1.09 meters, and the ball having an initial velocity of 1.3 meters per second? Neglect the weight of the ball and air resistance. The average time is approximately 0.9 seconds. First, we recall projectile motion. Projectile motion is a form of motion in which a projectile is thrown near the Earth's surface and it moves along a curved path under the action of gravity only. The implication here is that air resistance is negligible.
Ang lupit mo, pick up!
In this problem, we are given an initial velocity of 1.3 meters per second, time of 0.9 seconds, and distance of 1.09 meters. We need to find the value of theta. We can use the formula x is equals to VO cosine theta t. By substituting the values, Jeff's arm must be 21.31 degrees from the horizontal in order to shoot the ball inside the cup.
Malapit na ako ng... No.
Our second topic is about free fall motion. Free fall is any motion of a body where gravity is the only force acting upon it. In this video, we're gonna show an example regarding free fall motion. A ball is thrown vertically upward with a speed of 8 meters per second. How high does it goes up? And also, how long does it take it to reach its highest point? Neglect air resistance and the weight of the ball. We need to use the formula Vf squared is equals to Vi squared plus 2As to solve for the maximum height it attained. By substituting the values, the maximum height it attained is 3.262 meters. To solve for the time at the maximum height, we can use the formula Vf is equals to Vi plus At. By substituting the values, the time at the maximum height is approximately 0.82 seconds. Our third topic is rectilinear or straight line motion. This is a type of motion that describes the movement of a particle or a body. a body is said to experience rectilinear motion if any two particles of the body travel the same distance along two parallel straight lines. In a basketball game, player A is 1.5 feet ahead of player B. Player A has a velocity of 7 feet per second. Player A wants to shoot the ball 24 feet from the half court. What should be the speed of player B so that he can catch player A assuming velocity is constant? In this problem, we can apply rectilinear motion because both player A and B are traversing a straight line. We first draw the problem. By analyzing the drawing, we can solve for the VO by using rectilinear motion formulas. We can solve for the time of player A to reach the bottom of the ring by using the formula S is equals to VT. By substituting the values, player A will reach the bottom of the ring in 3.21 seconds. We now know that player B will only have 3.21 seconds so he can alter the shot of player A. What initial velocity player B must have so he can block the shot of player A? Use the formula S is equals to VT to solve for the velocity. By substituting the values, player B must have an initial velocity of 7.5 feet per second in order to chase player A.
It was at this moment that he knew. He fucked up.
Our fourth topic is about Newton's second law of motion. Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the object. A ball having a mass of 0.63 kg is dropped from rest at a post with a height of 2.4 meters. Compute the final velocity of the ball. Neglect air resistance. We can solve the acceleration of the ball by using Newton's second law, which is F is equals to ma. By substituting the values, the acceleration of the ball is 9.81 meters per second squared. To solve for the final velocity of the ball, we can apply the formula for rectilinear motion, which is Vf squared is equals to Vi squared plus 2As. By substituting the values, the final velocity of the ball is 6.86 meters per second. Our last topic is about work energy theorem. Work energy theorem states that the work done by all forces acting on a particle equals the change in the particle's kinetic energy. The work energy theorem can be derived from Newton's second law. A block is sliding down an inclined plane that makes an angle of 55 degrees with the horizontal. The coefficient of kinetic friction between the block and the plane is 0.17. What is the velocity of the block at S is equals to 0.5 meters? We can get the velocity of the block at S is equals to 0.5 meters by using the work formula. We first draw the FBD diagram. By analyzing the drawing, The velocity of the block at s is equals to 0.5 meters is 2.66 meters per second.
And we're gonna let it.
Go.
Hello, I'm Jeffrey Ramos from Group 3, Sweat.
Malapit na ako ng... No. To all my fans out there.
Kung wala